Good afternoon. Stephen Elliott of Coherent Breathing here. It is April 6th, 2025. Thank you for joining. Picking up where I left off in the last video, here is a view of the chest, an X-ray of the chest showing the rib cage and the diaphragm. And what I've done is superimpose the construct of the lungs and of the diaphragm, showing the diaphragm in its upper and lower positions. Now, you may have heard me say before that the sine wave is the signature of nature. And I say this because all of nature is vibratory, and all of nature tends to vibrate naturally in a sinusoidal manner. The reason this is true is because the sine wave is the most efficient mechanical action that can be taken here, at least on Earth and our gravitational environment. And this is true for the body as well. And we are breathing to help move blood and fluid in the body against gravity, inhaling, drawing blood upward from the legs to the chest, and exhaling, sending blood further upward into the brain and, of course, to the extremities. So one of the things that's very interesting about coherent breathing, and really another subtle principle regarding protocol, is that we try to employ the diaphragm in a sinusoidal manner. That is, we want it to move in a sinusoidal rhythm. We'll talk more about that rhythm, and I'll show it to you on an oscilloscope in the next video. You may recall this graphic from a video or two ago. Here we can see the Valsalva wave rising and falling in the upper panel, very much emulating a sinusoidal pattern. And below, we see the same signal now picked apart so we can see its component features, that being the red graph being the blood and the blue graph being the heart rate, where they are varying very much, again, in a manner emulating a sine wave. To find out how closely one can approximate a true mathematically generated sine wave, I performed this experiment where I have a adjuvant signal generator generating a sine wave at precisely 0.085 hertz, which is the frequency of resonant breathing, coherent breathing, you may know. And I breathed along with that sine wave using Valsalva Wave Pro. That is the red graph showing the blood volume changes in my earlobe as I am breathing along with the adjuvant signal generator signal. So here we can see that they are almost identical, sort of proving that it is possible to move the diaphragm in a sinusoidal manner, and B, that if we practice doing that, our breathing can approximate that of a sine wave. And again, a reason for doing this is that the sine wave is the most efficient mechanical action that one can take regarding almost anything, but in this particular case, regarding our intentional or conscious movement of the diaphragm. And along with that movement of the diaphragm, the movement of blood in the body, and along with the movement of blood in the body, the movement of the remaining 37 liters of fluid in the body. blood making up only 5 of the 42 liters of fluid that exists in the average adult body. The remaining 37 being principally cellular fluid, but also intracellular fluid and other specialized fluids, including cerebrospinal fluid, that which flows in the spinal canal and in the brain. And that's our video for today. Thank you very much for your interest.